Okay, ladies and gentlemen, let's take a look at surface area of a cone. Now, for surface area of a cone, again, we start to run into some of the same troubles and the same differences we had with the difference between pyramid cone as we did with cylinder versus prism. Because with the roundness of the shape, it creates some differences. But we already know that for a pyramid, the surface area of a pyramid is base plus 1/2 PL. And that L is the length up the side of the pyramid, not the height of the actual pyramid. Okay, so we have base plus 1/2 PL. Well, a cone is very similar in the sense that you have a circle for a base and it all goes up to one single point. But now when we talk about base for surface area of a cone, we say the base is going to be pi r squared. So we have pi r squared plus 1/2. Now the perimeter, again, is now a circle. So we need the perimeter of a circle, which is 2 pi r. Now, you still need the length down the side. So that's still going to be L, and we'll do that. But you'll notice the 1/2 and the 2 can cancel each other out. So pi r squared plus pi r L. Now, here's why this all works. If I take and make a cone, now I have a cone and I've made it out of paper, okay, mainly because it's exceedingly hard to get an actual cone made out of wood. So, but it is clear that you have a circle on the bottom, just like the little snow cone cup, and you have a cone right here. So you would definitely, if you made a net for a cone, you would have a circle for the bottom, pi r squared. But then is where you have a little bit of difference. If I unroll the lateral surface area, I actually get a big sector, okay? And the sector has a radius that equals the side length, so L. So I get some sort of a sector, and it would look like this. And this dimension here would be 2 pi r because it would have to wrap all the way around the circle. And the length down the side, the little L, is going to be the radius of this large sector. Now, depending on how many degrees you have determines how wide and how flat this is. So if I had a whole bunch of these with the same height, but a lot more of them, it would be a much more flat cone rather than the way I have it drawn where I only did about 1/4 of a circle, and that gives me a very tall cone. Now, obviously, a shape like this should remind you of at least one historical object, and that historical object should be a teepee. So let's take a look here. In this case, they're laying out a new teepee that's made in an old style. It's called a Sioux teepee. And the Sioux teepee, you can clearly see, is a large sector. In fact, they use almost a half circle. And so when they're done, it will have the traditional look of a Sioux teepee. Now, technically, theirs is not a perfect sector because a Sioux teepee is actually longer in one direction where the door is to prevent wind from blowing it over. So a little history lesson along with your cone lesson. So, but there you go. You go down the wiki rabbit hole and you end up in teepees. So you have cones, surface areas of cones. Now, thus far, we've been talking about right prisms and right cones. Take a look at this guy. This guy is also a pyramid. Now, whereas this pyramid is a right pyramid where the distance is up the center, this pyramid, its right angle is over at the side. And we talked about how volume doesn't change whether you draw the height at the center or whether you draw the height to one edge. the volume of these two would actually be exactly the same. Volume 1 equals volume 2. Likewise, in a cone, if I have a nice right cone versus a cone like a spotlight, as long as the heights are the same, so I drew that one a little too tall, but if the heights are the same and the radii are the same, the volume are going to be the same. But over here, just like in a non-right prism, you can't use the same basic surface area formula, a base plus a base plus 1/2 PL, because here you're going to have a base plus one side that is a weird triangle that kind of looks like this, and another side that is a triangle that's similar, but then you're going to have this one weird one up the middle, and then you're going to have this wide fat one that looks like this, plus your base. So you would have to add all of these different shapes up for non-right. So you can't do the basic formula for a non-right pyramid in the same way. Whereas our cone made a nice sector, if it's right, a non-right would be a total mess and it would be elongated. So your surface area equals pi r squared plus pi rl only works for right cones and right pyramids. So make sure you know that the other shapes you'll have to wait on, just like when we had the oblique cylinder, we had a mess here to deal with. So a couple things to take a look at.